Welcome back, everyone. Yes, we truly understand post-lunch hours. It's a little intriguing. It's a little difficult to sit, but let's sit and let's maintain this beautiful smile that we have been since morning. And it's time for the next session now. That is optimize carbon footprint of your code and containers. The new Sustainability KRA for developers. And this session will be led by Vinay G Rajagopal, ISV Technology Lead Architect for Partner Ecosystem RedHat. Vinay Rajagopal is Technology Lead Architect and Partner Ecosystem at RedHat. As a technology lead, he is responsible for helping independent software vendors, including IoT, AI, ML, and emerging technologies-based partners to build products on Red Hat stack, accelerate containerization, and enabling them on go-to-market strategy. Let's welcome Vinay G Rajagopal with a huge round of applause. Very warm welcome, Vinay.
Thanks, Swati. Good afternoon, everyone. Thanks, Swati, for the introduction. Like she alluded, I think the toughest portion of this entire session is going to, keep you guys awake. Ask me why, because mine is the first session after a good lunch. Well, most importantly, I think the biggest reason and the climate change that we're seeing of course, post-COVID and all of that has tremendously changed the way we operate, right? And that's why I'm here to talk about how can I reduce the carbon footprint. How many of you guys here are developers, product owners, product strategy? If you could raise your hands, tap your back. You are the guys who build the IPs for them, right? You are the differentiators. Now, how many of you guys here are operations team, SREs, delivery teams, and so on and so forth? Can you please raise your hands? There you go. Very good. Now, you also have to tap your hands because they build it, you ensure it, it works fine. Now, all that we do is to keep the lights on, right? How do I make sure I go beyond and, most importantly, bring the whole sustainability aspects, right? On that note, let me get started. Is this working? It looks like the slides are going way ahead of the schedule. Okay, so where are we in terms of carbon footprint and why it's important, right? If you see ICT, the estimates that a lot of marketing analysts gives us in terms of the data insights, in about 2020, we were at 4%, and the estimates for 2025 is about 8%. That's 100% raise. Now, that estimates have not taken account of the spur that we see in terms of technologies, right? Like blockchain. Blockchain is a compute-intensive technology. It requires a lot of compute power. IoT requires a lot of power, electricity consumption. Of course, AI technology, it needs to run every time. It doesn't matter. AI is the only technology that doesn't sleep, right? It needs to keep inferencing. It needs to ensure that it derives the data appropriately, right? And then give you all those insights. Now, on that note, we see that this is going to be huge. 8% estimate, it's going to be much more than that. Now, what is that is leading to that, right? Why is it important for the CEOs? Now, if you see the data in 2019, it's always been as one of the priority. It's never been the highest priority. And with that, what happens is, I'm sorry, it's flipping through. Is this working, guys? Is this working? Oh, you have another one? Yeah, yeah. Yeah, I want to go back. Yeah, it's not going. Yeah, now it's good. Yeah, just keep it there. Just keep it there, yeah. We good? No, it's moving by itself. Yeah, just keep it there. Yeah, it was changing. See, it's gone back. I didn't do anything. I don't know. Yeah. Is it working now? Just stay there. Okay. Looks. I don't know. Okay. Sorry about Murphy's Law. So like I said, for the top CEOs, right, it's always been on their priorities, but it's never been the highest priority. It's never been in the top 3 at least, right? Now, what's happened after COVID, right? If you see the analyst data for 2022 and 2023, of course, there's a spur again, there's a spike in terms of the sentiments towards workforce. You see 214% increase in the workforce, right? And you also see for ESG and the health and security aspects have also taken that spur. So all of a sudden, you see the sustainability, the sustainable computing, the energy consumption, and so on and so forth has taken that high priority now. This is all good. We understand it's the need of the hour, but can I shoot in the dark? Probably not. So there needs to be some method to the madness. How do I measure? Because I cannot manage anything unless I measure it, right? And we see this roughly about 85% of them have put that into their priority list. They're willing to consider their ESG reporting, which is also compliance requirements. It's about 9% of the organizations who have told that we already have started in some kind of measurement capabilities and the ability to report that back. And there are that 6% that you don't see the number there who are still probably figuring out what is that they have to do. Now, this is good. We've understood the importance. We've understood the need of measure it. But where do I start? I'm a developer. I'm a product strategy. I'm the CXO. But where do I really start? So let's look at the entire span, right? So you have the power grid. You have all the HVACs. You have all the backup generators. And, of course, the fuel. You monitor the fuel levels to make sure the fuels are optimum and there's no downtime. Now, that's your data center. Now, you move towards the IT facility, right? That's where your compute, your storage, your network requirements come in. And then, of course, everything after that, right? The backbone in terms of networking. Now, all of this also requires a lot of cooling systems, right? Because they have to ensure there's not much heat dissipated and there's no failure of these equipment. So you have these cooling systems, what we call HVACs typically. This is what is the footprint, from an IT perspective at least. How do I really look at it? Now I know what are those various equipments, what are those various footprints that leads to energy consumption, but how do I translate into a practice, translate into a framework that I can then apply, right? Now, that's where the importance is. Now, if you look at what I've done is a combination of on-prem and a cloud footprint. So it gives you gives you a perspective from a hybrid also, which is what the industry is heading at least. So all the power and cooling efficiency, which is again from your HVACs, ability of hardware vendors giving you some kind of an efficiency to say this is how I use less power. The compute utilization is where the IT part comes into picture. Now, all of this is typically infrastructure oriented. Now, how do I bring in software engineering practices? How do I bring in cloud native application, modern technologies, at the same time have a very well-defined application optimization? So what I've done is broken that into 3 stages. One is everything that you have to do from a hybrid cloud infrastructure, and how do I bring in the measurements? Because there's not much we could do. We only bring in the measurements, we apply insights and see how we could improve the efficiencies. Now, the second one, like I called out, the sustainable software engineering practices. The last one is application optimization by design. How do I ensure every developer here, every SRE, every operations team here can bring in some level of optimization, even at the application level, not by default, but by design, to make sure we are moving towards a sustainable computing. How do we do it? We've understood, the different components, how they all connect together. How do I go about doing it? So we have what is called an open source CNCF project called Kepler. Kepler stands for Kubernetes Efficient Power Level Exporter. What it does is basically it exposes various metrics, which is basically of the Kubernetes components itself, like the Kubernetes API server or the various workloads that you define, right? You have various container workloads that runs on pods, that runs on nodes, on a specific namespace. So you have an ability to look at the power consumption, the energy consumption of each of those various computes. Now, that's good. How do I bring them all together, right? When I bring them all together, right from any footprint perspective, that's, again, very important. You're not looking at just the hardware. You're also looking at the edge footprint, which is an extension of hybrid. You're also looking at a virtualized environment because you're pretty much hybrid right now, right? You could run anywhere. And for an application developer, that's what matters. I should be able to run my application workload pretty much anywhere. So the insight has to be from the operating system level all the way to the application, the pod consumption, and then you aggregate all that data, you slice and dice, bring those insights and report that as a part of your ESG reporting. Also, what you could do is to plug that into your observability consoles so that you could then take proactive actions if there's an uneven or undecided state of operations, right? Now, that's good. You kind of understood on the infrastructure layer, what can I do from an application perspective? That's a big question that all the developers would have. That is where what we have is another open source project. And I repeat and I emphasize that open source because all of you guys can go to GitHub, download it, and can start consuming it. It's absolutely open source. The codes are open. You can start utilizing it right away. So when we talk about Quarkus, it's a microservices framework. Again, gives you a fast boot time. It also has a very, very low memory footprint. And the most important one is the near instant scale. You could scale up even when there is high density memory, right? Now, what that means to you is, you compile on lifetime, you shift left the entire development process, you test your containers through either OpenShift local or a local deployment of Kubernetes, and you push it to whatever your UAT, SIT, pre-prod, production, and so on and so forth. So, two things to look at it. Both of them are the different sides of the same coin. One of them is the infrastructure level. The other one is from the application perspective. So when you bring both of those together, you have, from an IT perspective, you have that visibility to your energy consumption. Now, we did all the techies here, right? You want to know, how does the numbers look? How does the test look, right? Of course, test is subject to a lot of, varying workloads and the whole set of parameters. But I want to bring to your attention is 50% of reduction of, compute capacity when Quarkus was used. What we've also seen is Quarkus is available as cloud native, more from a Kubernetes perspective, and also available as a JVM, so you could still run your, your typical workloads, which are stateful and still reach a JVM. So we looked at tremendous 50% fall, even for your, typical crude operations. Now, with that notion, what is very important is how do you application developers bring those three things into picture, right? The first and foremost, low memory usage, and that leads to higher throughput using the same set of resources. My ability to get more work done from them are more, which means I'm getting things a lot done with the same amount of lower resources that I had. First and foremost importance from an energy consumption. How much of energy you're using, your codes are using. Secondly, it is the machine, right? Because you don't want to scale unnecessarily. You don't want to size it for some capacity which is probably for a Black Friday or a Diwali sale. How do I really consume less? How do I scale out when there is a need? And not just scale out, but also scale down, right? That's the elasticity of your application. Can I nearly scale down to 0 pods? Can I bring in serverless capabilities? Can I plug that into my applications and run a more event-driven architecture? All of that is what Carcass brings to you. So you as a developer, you as an operations team, from an infrastructure perspective, from an application optimization perspective, you bring both of them together. Now, what that does mean is, are we reducing carbon emissions? Yes. You're saving time, you're saving on the consumption of money because you save time and you save the resources, and you're also saving carbon approximately 2 times, right? 50% what we looked at it. But we saw the variance, right? I don't know if you guys noticed it, but the variance of using it on a cloud native versus using it on a JVM, you need to understand this. This is very important for developers. It depends upon your workload. For example, if you're looking at a use case which is more for native, right, which is typically an edge footprint, where there is very low workloads, but the throughput may not be a bottleneck. And if the throughput may not be a bottleneck, what really happens? And that is where you could look at cloud native aspects, which are typical, again, edge means resource constraint, power constraint, right? How do I take a look at that, right? That is where Carcass, the cloud native, Kubernetes native, compiler comes into picture. Now, if it is edge, another important requirement that I have is my ability to scale, my ability to deploy at hundreds and thousands of devices. Again, that's where the deploy rate comes into picture. And of course, serverless, like I said, can I adopt serverless technology? Can I write functions as a component that I can plug in, right? So the whole functions as events, right? So that I can then have some events that triggers the compute to stand up. And otherwise, the compute is absolutely zero. So for everything else, where high workload, you need throughput, that's where the JVM comes into picture. So keep in mind, anything which is a long-lived process, anything which is stateful applications, you probably need the JVM there, right? And the stability, of course. Now, can I use this or that? And the big question is, everything's going hybrid right now, right? When I say hybrid, you have to be ready for any footprint. You cannot afford to have it on one hyperscaler, one public cloud service provider, because what's your exit strategy? You need to ensure that you build your architecture which are capable of being deployed, being operated across any footprint. Like I said, including edge, because edge is becoming a reality with all the 5G technologies that are coming in. Now, one of the key strengths of Carcass is that your application code does not need a change. It's the same whether you run it on native or a JVM. The compiler itself makes all those necessary changes. So that gives you an edge. It doesn't matter what sort of application you're running in. So what it means to us, what it means to all of us here is optimizing cost, optimizing application performance, also leads to optimizing carbon. So all of us here are in fact leading into lower energy consumption and lesser carbon footprints, right? Now, what it means to all of us is reducing energy consumption can make everything better. It's not just about energy consumption. It's not just about carbon emissions. It's also about the climate change, right? It's also about water consumption. It's also about managing those e-waste. So it's tremendous impact that it has, and we all believe, I'm sure all of you guys, everyone here would believe that we all have a part to play. Either we're developers or we're operators or we're in the IT field. Sustainable computing is absolutely important, and I want all of you guys here to take back this key message that you guys can go optimize your codes, optimize your containers, and start reporting what is the level of energy consumption. And both of those open source projects are available on GitHub. Go fork it, play with it, and I'm happy to hear from you guys anytime. That's it from me. Thanks again.
Thank you so much. Kindly stay with us. stay well. Thank you, Vinay. I'd request Ashish Gupta, Vice President and Head of Software Barco, to kindly come on stage and felicitate Vinay.
Yes, yes. Good to meet you. Thank you. Thank you, Ashish.
Thank you, gentlemen.